chips. Oh. You're doing so bad. I got the bread right now. I got the bread. Okay, I'm sorry.
Alright, so today's stuff, we're going to be mostly focused, well, we are going to focus all on linear stuff. Okay, so everything's going to be just linear. So anytime, and I don't know how they come up with all these words, but that says modeling with linear functions. That just means we're going to be putting it to a real world scenario. So it would be very similar to this problem right here. This function that you wrote on number 11 on yesterday's assignment is linear, because this is mx plus b. So you could model the farther you drive. If you think about an x and a y axis, the farther you drive, the higher the price goes. So those are both going at a constant uphill line, right? So that's the kind of stuff that we're going to be looking at here. So let me get a piece of graph paper. You don't necessarily need one, but I'm going to use one. There we go. Alright, so let me get this little segment drawn here that we're going to look at. I'll use some straight lines. Try to be fancy since I got fancy tools. This Senor Cox makes fun of how I say fancy. So I say it all the time to Booger. That's fancy. Fancy. This is distance in miles. And this is time in seconds. We're going to start at origin. Okay, I'm not going to count. You ready, Garrett? I'm not going to count on this graph and get all this specific, because that would take forever to. What we need to know is that we have a line there, and that my line goes through the origin. And I'm going to give you one other point that it goes through. We're going to say that this point that it goes through is 524. Okay, so no, I didn't count that, but that's all we need. So that'll save us a little bit of time. So the problem that we got here, it says the graph shows the distance that asteroid 2012 DA14 travels in X seconds. So this asteroid will go that many miles in that many seconds. It wants us to write an equation for the line, interpret the slope, and then after that we got another question that we're going to answer about it. So write an equation of a line. So this is going back here to nothing but some good old Algebra 1 stuff. There are lots of different forms for something linear, and we've already talked about that one. That is the most common. That is the easiest one to work with. That is the one I'm fixing to use. That's called slope-intercept form of a line. Does that ring a bell? I've seen something like that before. There is also what is called standard form of a line. Something x plus something y equals something. Those a, b's, and c's would be numbers. Okay? There is what is called y minus y1 equals m times x minus x1. Anybody know what that one's called? Y minus y1 equals m times x minus x1. It's a line. Anybody know the formula that line is in? Okay, it has a, what does m stand for?
Slope.
Slope, thank you. It's got a slope, and then it's got an x1 and a y1. So it's got a slope, and it's got a point. That's called point-slope form. Very good, point-slope form. So those are your three most common types. If you've got the info, this one's the easiest, and we have this info. Okay, what is the B on that line about our asteroid? B is y-intercept. Where does this line cross the y-axis? 0. So if I'm thinking y equals mx plus b, I already know I've got a 0. Okay? M. What can I do to find the slope of that line? Now, I created a dilemma for you. We're going to use it, but I can't directly count rise over run here. That is a way to find the slope, but I didn't actually measure and count those out, so it's not drawn to scale, so I can't really count rise over run. But based on what I gave you here, from the bottom, from 0 to that point, you know how much it rose. From here to here, how high is that? 24. So your rise is 24. Okay, now from here to here, what's the run? How far is that? 5. So rise over run. Right? Okay, now you can leave that because that doesn't reduce, so you can leave it as 24/5 if you wanted to. I don't have a problem with that. Most of the time when it's slope, you will leave it in a fraction because it does mean rise over run. But we're fixing to try to make this make sense to some asteroids in some seconds. So this might be an okay time to convert that to a decimal. So see if you can convert that to a decimal. Just do 24 divided by 5. Thank you, Bill. I was about to scream if nobody went for it.
Oh, that would be 4.8.
That's very good. Garrett, good mental math. Y'all check him out.
I don't know, I don't need calculators.
Okay, so we're going to say y equals 4.8x. Now, do I need to write the plus 0? I can, but I don't have to. Leaving it off is the same as plus 0. Okay, I've already talked about saving smartboard ink. So 4.8x. So this equation represents that line. Now what I want us to think about, the next question that the book asked after we write the equation, and by the way, that also means function. You wrote a function. Doesn't that make you sound smart? What'd you do at school today? I wrote a function. Well, I mean, that's big time right there. So, no, she give you a high five. So after we wrote the function, it asked us to describe what that slope means in relationship to the problem. So what we have here happening on our problem, this is some asteroid that the scientists are tracking. This is how many miles it goes, and this is how many seconds it goes. Now notice miles is your y-axis. So miles is going to be what this equals, the total amount of miles, right? X is your x-axis. So you're going to be plugging in seconds right here. So you're going to do 4.8 times the number of seconds, and that'll tell you how far the asteroid has gone. So how could we describe what 4.8 is to somebody that doesn't know?
4.8 miles.
I'm seeing some head shakes.
Is that wrong?
Well, it's a little bit. It's not completely good yet. We're going to work on it.
I was close.
What else? Garrett's not the only one that can talk. Y'all think it.
Wouldn't you times about 24 though? It's 24 seconds, right?
No.
Oh no, 5 is it?
So if you did 4.8 times 5, what would you get, Garrett?
20. You get 22.4.
No, you don't.
Ah! $24.
Yep. So you just confirmed that our equation is right because you plugged in the 5 and got 24. My question to you still is, what does the 4.8 mean in relationship to this problem? Go ahead, Tori. That's exactly right. That asteroid is traveling 4.8 miles a second. Now, it's hard to imagine, but that's pretty fast. 4.8 miles in 1 second. So when I say it's already gone almost 5 miles. That's pretty fast for an asteroid. So anytime it's time and distance like that, your slope, that's what your slope is going to represent. How far and how long. So in our case this time, our how far was miles and our how long was seconds. Okay, so the asteroid Garrett's going 4.8 miles a second. All right, what I want to do with this now, this says the asteroid came within 17,200 miles of the Earth on a certain date. How long did it take it to go that far? So it came within 17,200 miles. So let me find a new color here. We're looking for 17,200 miles. Right now we've only gone to 5 miles. So we're trying to make a big old stinking jump to 17,200 miles. But you know, and we've already discussed where I could plug 17,200 into this equation. Did the y stand for miles or did the x stand for miles?
The Y.
The Y, because it's on the Y-axis. You with that? So I can say, put the 17,200 in for that Y, right?
Yeah,
so
then divide by 4.8.
You're right. 17,200 equals 4.8x. Now I'm trying to solve for x in Algebra 1 review. Garrett said I'm going to divide. Because it's being multiplied, we undo that. So we divide both sides by 4.8.
And that'd be 3,583.3.
So x is 3,583.3 seconds. Okay, so to get 17,200 miles, the asteroid took 3,583 seconds. So what does that mean? If you told me, well, I'll meet you in 3,583 seconds.
Divide that by 60 and that'd be
So we could maybe convert this and get a more realistic measure. So what he's doing 60 because there's 60 seconds in a minute.
So we're looking at 59 minutes and it says 59 plus.
Okay, so would this be an okay estimate here? Could I say that this asteroid traveled 17,200 miles in almost an hour?
Mm-hmm.
So that's what that means. You just got that by dividing by 60 and seeing that was pretty close to an hour. Okay, so you could make all different types of conversions on this. Now, think about where it would take us to, how long, where is an hour away from here that you go?
Little Rock.
Oh, Little Rock's on an
North
hour
Little
away. Okay, so maybe North Little Rock, depending on if we start in here or in Benton, but
I'm not drive slow, so.
But take us an hour to get from here to Little Rock about, so you're talking about 40-ish miles. This thing's going 17,200 miles in the same amount of time we're going 45-ish. Pretty fast. Pretty fast.
Fast rocket.
Asteroid. Better cover your head if you see it coming. Asteroid.
There it is.
Okay, let me tell you about what we got rocking right here. New problem here. You ready? It says two prom venues charge a rental fee plus a fee per student. The table over there on the left in black, the table shows the total cost for different number of students at the Lakeside Inn, if that was where we chose to have a prom. The total cost in dollars for students at the Sunview Resort is given by that equation over there on the right in blue. Okay, so we've got two choices for where we're going to have the prom. We could have it at the Lakeside Inn. If 100 people go, it costs us $1,500. If 125 people go, it costs us $1,800. Okay, or we could choose to have it at the Sunview Resort, and they just gave us that equation there. So our question says, we got two questions. Which venue charges less per student? How many, that's number one. Number two, how many students must attend before the venues are the same? So there's going to be some number of students that it wouldn't matter which one. All right, so I'm going to tell you that on the blue over here at the Sunview, I already know how much it charges per student.
It's $15 a student. Lakeside.
Okay, but I'm on Sunview right now. Hold on to that thought. How much is it per student at Sunview? How much? Hunter, say it loud and proud. $10 a student. Okay, $10 a student. Hunter got that from the slope. So just like before, this is total cost. This is how many. So if there's 2 people, you do 10 times 2. If there's 3 people, you do 10 times 3. So it's going to cost $10 a student. Now some of us were looking at that 600 and saying that. Do yourself a common sense check. Would you go to the prom if it cost you $600 to go? Then you got to take a date. It's going to cost $1,200 to go. So that should have threw up a red flag for you there, right? So $10 a kid. So we know Sunview. We know Sunview is going to charge $10 a student. So what about that 600? That's got to mean something. Right. Somebody said it. Was that you, Bradley? It's just their fee for their building. So before they'll even come unlock the door for you, then you've got to pay an additional $600. So it's a $600 like rental fee.
So if you have 100 students, it'd be 16 apiece. Wouldn't it? Because you don't have to add 6 to 10.
Yes. So you would do 100 times 10, and then add 1,600 or add 600 to it, and then go back. Yes.
So it'd be actually 16 if you have 100 students. 16 per person. Because if you do 600 divided by 100, it's 6 per person. It's actually 16 per person. Right? That'd be right, wouldn't it?
I think so, but you're confusing.
I'm pretty sure.
$10 times 100 students, that is 1,000 plus 600, so 16, and then you said 100 students?
Yep.
So divide, yes. That would
16,
be.
and you got
Yes.
6, so 16 actually a person.
Yes. Okay. We don't need to know that yet, what Garrett was talking about. All right, over to the lakeside end now. We know everything about, we know how much Sunview's going to charge per person. We know how much we got to pay to rent the joint. How much is it going to cost per person at Lakeside Inn?
$15.
Okay, Garrett thinks it's going to cost $15. Let's see if we can figure out how he thinks that or if that's right or wrong.
Because if you do 1,500, that's right.
Okay, do we have anything consistent happening in the number of students on this table?
Because 15 times 100 is...
Okay, slow down, Garrett. It's going up 25. Do we have anything consistent happening here?
It's going up 300.
It's going up 300. So my rise is 300. My run is 25. So what's 300 divided by 25?
12.
Okay, so far we know that Lakeside Inn is charging $12 per student. Or person, I think I wrote person over there. $12 per person. So what if I check that here? What if I did 100 times 12? What do I get?
1,200.
1,200, but they're saying it costs $1,500. So what does that mean?
So it's actually $3. It's actually 15 a person.
Slow down. That gets on my question.
All right.
12 times 100 is 1,200, but they're going to charge me $1,500. So they've got one of those stinking fees like this place. How much is their fee?
300.
300. So they got a... Right with the wrong end. They got a $300 fee.
So it's $3 more.
Okay. So now, since I know this, could I make it into one of these equations? Okay, so wouldn't this read y equals what? 12x plus 300. Okay. All right. Whole point in doing that is we're trying to decide which one of these places we're going to have the prom at. And when we compare two things, you can't compare them when they look different. So you either needed both tables so you could compare them the same, or you needed both equations so you could compare them the same. So we got that knocked out. All right, so our first question says, which venue charges less per student? You can see that now. We've written up there that Lakeside charges $12 a student. Sunview charges $10 a student. So when it said which one charges less, you would say Sunview. Now does that mean that's the better deal? What does it depend on? No. Depends on how many kids go, doesn't it? Because like Garrett's been trying to speed y'all up to find out over here that as the number of kids change, the price that you actually divide out goes down. Because like for instance, if our school's having the prom and we're choosing one of these, they're not just going to say, okay, everybody pay me $10 at the door, and then whoever's in charge of prom is going to pay the extra $600. You think that's going to happen? No. So they're going to spread that out, and your $10 is going to go up a little bit. Okay, so that's what we got to figure out now. Which one, depending on how many people we take. So I could, I've got a lot of color options, take the meet here. If I'm looking for where it would be the same, what does same mean in math? Equals, set that equal to the meet we have here, and whatever my number of people is would be where it would be the same. Okay, so let's say 12x plus 300 is equal to 10x plus 600. And we've created an equation to solve. What would I do to start solving this? Okay, I would do what Tori said, and I would subtract 10x, but if you chose to start that somewhere else, it's not wrong. You could solve this equation several different ways, but I like to start with my variables, and I like to keep them positive, so me and Tori would have been on the same page. Okay, now you've got just a plain old two-step middle school equation. So Tori doesn't have a choice now about where to start. What do we have to do here? We're going to subtract 300 from both sides. So our 2x is equal to 300. Last step. Divide by 2. So if I have 150 people, if 150 people sign up to say they're going to the prom, I could pick either one. Whichever one has a better view, whichever one's closer, I can pick either one. Because it's going to cost the same, because that's where those were equal. But what about if I have less? Which one would I want to pick? How can we figure that out? I mean, there's a lot of right answers here, so don't be afraid if your answer's not what somebody else says. I think the common sense thing to me would be just to pick a number less than 150 and check it in both of your equations and see which one's cheaper. Wouldn't that be one way you could do it? Or you could pick a number bigger than one, if you wanted to know the other way, pick a number bigger than 150 and plug it in. Or you could, instead of an equal sign, you could solve this as an inequality problem. You could put a less than or a greater than sign in there and work out that way. There's lots of different ways. How much would, since we know 100 people are going to cost $1,500 here, how much would 100 people cost here? And we've already done it a little bit. Can you see the equation still? 10 times 100 is 1,000. 1,000 plus 600 is 1,600. So if there's 100 people, this one's 1,600, this one's 1,500. So this one's cheaper, right? So I could assume that if I have less than 150 people, I'd want to go with Lakeside, right? Okay, let's look at 200 since they already gave us 200. 200 at Lakeside would be that much. 100 times 200 is 2,000. 2,000 plus 600 is 26. So this one will be 2,600. That one will be 2,700. So now this one is cheaper. So if I had more than 150 people, I'd go with the Sunview place. Okay? So all of this, because there was no new math there. We didn't do one stinking thing new. That was all Algebra 1. But all we did was took that Algebra 1 stuff and expanded it to put it to a real world problem, and we just banged it to death. We did more than you ever wanted to do with that. I bet y'all didn't go do that much with lines in the past. Y'all probably just graphed it and ran off, didn't you? That's what I figured. What a figure, what a figure. Alright, good stuff. I like it. I like it a lot. Can we do one more?
It's 45.
I think we can do one more. We can probably do 3 more, but we'll do one again.
3?
Yeah.
It was like 10 minutes more.
Maybe we'll speed up.
Be like that asteroid.
That's right. so let me read what we got going on here before we go a little bit. This says the table shows the femur length in centimeters and the height in centimeters of several people. So if you went and measured this person's femur and it was 40 centimeters, and then we measured how tall they were 170 centimeters. Okay, so everybody see what we got cracking there? It says, I don't know if that's proper English or not. Do the data show a linear relationship? If so, write an equation for the line of best fit. So we're fixing to see something new that we haven't seen yet this year. You've seen it before with the line of best fit. So what do I need to start doing here if I know that a line of best fit could come into play, and if I know I'm looking to see if this is linear or not? What do I need to start doing with my data? The line of best fit might come into play if it's linear, and I need to be able to tell if it's linear. What do I need to start doing right now? I could put them in order. I'm not going to, but that wouldn't be wrong. I'm just trying to save some time so Garrett doesn't whine.
Wait, what?
If I'm going to draw a line of best fit, I got to draw it through some points. So I probably need to put these things on a graph, right? Okay, so this is going to be a scatter plot looking thing. Now, which one's the X and which one's the Y?
The femur.
Generally speaking,
It's
your
really
first
small
column
number.
is your X and your second column is your Y. So I am going to put my femur on the X-axis, and I'm going to put my total height on the Y-axis. Alright, now my femur looks like my smallest one was 30, and my largest one was 50. So I'm going to probably do some, like, I don't want to count all the way on my height, especially all the way up to 150, so I can do those breaks and just make some estimates on that.
Maybe like 25
okay?
piece.
Alright, so I'm going to start here at 25, and I could go, well, let's go those by twos, since there's not as many of those. 31, 33, 35, 37, 39. Should have went more, huh? We're going fives. And when you're doing these types of problems on your own, if they don't tell you what to increment by, as long as you're consistent, you can increment by whatever you want. As long as you're consistent, you can't say, well, that space is 5, and now all of a sudden it's 12. You know, you got to be consistent. All right, I'm going to break here, and my smallest person, my shortest person is 141. So I'm going to start at 140, and I got to get to 195. So
Do 20.
do 20s. That's I want to spread that a little bit more.
Oh, yeah. So
Let's do
15.
10s. Alright, now I'm just going to, I got 195, so we're going to go to it. I'm just going to start estimating and plotting these points. Okay, so I got to go over 40 and up 170. Over 45 and up 183, over 32 and up 151, over 50 and up 195, 37, 162, 41, 174, 30, 141, 34, 151, 47, 185. Alright, so some of y'all are still working on your scatter plot. I got my scatter plot. What, you think it has a linear relationship? Does it look like I could take a line of best fit, a straight line, and draw it so that it represents the majority of those points? Yes. It doesn't, remember, a line of best fit doesn't have to hit every point. It just has to be a representative. So I think this does appear to be going consistently uphill, and I could draw a line that is representative of those points. Do they all hit exactly on it? No. But it's a line of best fit. Now, so the first question was, is it linear? We said yes. So that means now we got to write the equation for our line of best fit. Okay? What do you always need when you write an equation for a line? Slope. So you need to find the slope of that line. Okay, count, rise, over, run is one way. Your formula is what I'm going to use here. Subtract your y's and put it on top. Subtract your x's and put it on bottom. Now, does it matter which 2 points you choose? No, it really doesn't. But this is why everybody's line of best fit might not be the same, right? Because I might choose these 2 points to find the slope, and Laney Joe chose these two. Should be close, but it won't be exactly the same because we chose different points. Now, I would say to not use a point that I call an outlier. You don't want a point that's real far away from the line. You want to choose some that are pretty close to your line, right? Bless you. So I'm going to say, see, I'm not going to use that 195 one. So I'm going to say, I'm going to use these two. Okay? And I could have picked, like we said, any two that I wanted. So subtract my y's, and it doesn't matter which order you go in as long as you do the same. So if I do 170 first on my y's, that means I got to do 40 first on my x's. Y'all remember that? So 170 minus 51, is that 19? So I got 19, and then 40 minus 32 is 8. So there's my slope. Hey, there's my slope, 19 over 8. Now that's an ugly fraction. What's 19 over 8 the same as a decimal? 2.375. Alright, so I got a slope now. Do I have a B? No. And this one is one where I can't assume a 0 like we did on the car problem. Because you're going to get into when a femur length, well, before the baby's born, it has a femur length. So you can't assume a 0 on that. Okay? So I need to use point slope form. So this y1 and x1, Gary, you're about to get on my nerves. I can pick any point I want to off of that table to use. So I'm just going to use that 40, the one on the top that I started. So my y stays y minus my y1. The one I chose is 170 equals m, which we said was 2.375 times x minus the one I chose is 40. Okay, what would I do to simplify this to get it into slope-intercept form? What do you do anytime there's something right outside of parentheses? Very good. So I got y minus 170 equals 2.375x minus, somebody tell me what you get when you do 2.375 times 40. 95. And I only have one more step now to get it in slope-intercept form. Slope-intercept form needs the y all by itself, and right now it's got 170 being subtracted. So I'm going to add 170 to both sides. So for my final equation here, for my line of best fit, I got y equals 2.375x plus whatever negative 95 plus 170 is. So, everybody got that real fast? Plus 75. So that would be my final equation. Okay? Good job. Y'all have a fabuloso day. See you tomorrow.